Okay, welcome. Now, in this case, we can definitely go ahead and solve this by using our square root method. But again, the purpose of this course is to go ahead and solve this by using our difference of two squares. So therefore, we want to be able to see, can we apply the difference of two squares to this? Is this binomial a difference of two squares? So when having our difference of two squares, remember we have a squared minus b squared equals a plus b times a minus b. Okay. Now, in this case, what we see is we want to make sure that our coefficients or our constant are both going to be perfect squares. So we want to make sure that we can rewrite 1/4 x squared as a squared term and as 81 as a squared term. Well, we know that 9 times 9 is going to equal 81, so that works. But what is going to multiply by itself to give us 1/4? Well, we think of what two numbers? Well, 1/2 times 1/2. So therefore, I can factor this because x times x is x squared. I'll set this equal to 0, and then I'll break this up using our form for difference of two squares, which would be 1/2 x minus 9 times 1/2 x plus 9. And now I can apply the zero product property by setting these both equal to 0 and 1/2 x plus 9 equals 0. And this might be a little bit easier than using the square root method. But if you're having trouble with it, sometimes it might be harder. So now, that's an x there. So now I use my inverse operation of 1/2 times x. I'll multiply by the reciprocal, 2/1, which is really the same thing as just multiplying by 2. Doesn't really matter if you write it as 2/1 or just 2. You're going to get x equals 18 and x equals negative 18. So there you go, ladies and gentlemen. That is how you solve a quadratic by using your difference of two squares. Thanks.